NDBs, aka ADFs, sort of. So NDBs, you can find information on them in AIM 1-1-2 or IFH Chapter 9. But the NDB itself stands for a non-directional beacon. Inside the PTS is going to mention the ADF. The ADF is the receiver, this is the ground station. So the ground station NDB, right, it's going to broadcast signals 360 degrees around the transmitter. But unlike a VOR, these are not radios, it's just one signal beaming out. The ADF's job is to connect that signal and just point to where it's coming from. So what that looks like is this, right? So we'll say the something is the NDB. This is the little ADF receiver. So all it's doing is just going to constantly point to the NDB, like that, and that, and that. So regardless of where you are around the NDB, it's going to point to it. So in terms of using NDBs and ADFs to navigate, there are 3 different types of receivers or instruments you could have. The first one, and the most confusing one, is called a fixed card ADF. So before we get into this, we've got to define a few terms. We have bearing, and that word comes into play in a sec here, but bearing just means the course to fly to get to this object. So if I was right here south of the NDB, my bearing to the NDB is 360. If I was right here, my bearing to the NDB is going to be 270. Right here, my bearing to the NDB is 180. If I was going to this red plane here, right, my bearing to this red plane here from this position, I'll call that, let's see, that's 36040, let's say. It's the course to something, that's all bearing means. So to use a fixed card ADF, we have a little acronym. We have, I call it Mary Had Roast Beef. So Mary had roast beef equals magnetic bearing. So what this means, this is magnetic heading plus relative bearing equals magnetic bearing. We'll talk about what that means in a sec here. So magnetic heading, that's exactly the heading you fly. So this plane right here, its magnetic heading is 270, facing due west. Relative bearing is going to be what you're going to see off of the needle. So assuming this is north, I can move it. Okay, well, it's going to stay there. This is east, that's south, that's west, right? The relative bearing off of this NDB, this fixed card NDB here, is going to be 090. It's just whatever you read it in whatever heading it's pointing to. It says 090. So if you add these two together, it gives you magnetic bearing. It gives you the course to the NDB station. So if we go 270 plus 90 equals 360. So we fly a course of 360, we get to the NDB. Okay. How we can think about this fixed card actually. North is going to be your nose, if you picture that, right? So if the NDB is like right in front of you, like so, this arrow will be facing straight up, so it's in front of you. if the NDB is directly to your right, it's going to be facing to the right, at the east. If it's behind you, right, south. Can I get the point? Right. There we go. You can almost think of this as it tells you how many degrees to turn from your current heading. All right, so a few more examples with this fixed card here. Let's say we were traveling southbound, like so. So in this scenario, NDB would be like that. Or ADF, my bad. So magnetic heading is currently southbound, heading 180. So 180. Relative bearing equals 270 because it's off our left side. So our magnetic bearing would be 090. If we fly a course of 090, we get to the NDB. Do that. Right, then we get to the NDB. Boom. Cool, so that's the fixed card ADF. The other two are really simple once you get this one down. It's going to be your movable card ADF and then your RMI. So your movable card ADF, all this means we're going to readjust this here to the same scenario like that. Right, instead of doing the math of magnetic heading plus relative bearing equals magnetic bearing, this will do the math for you. You just got to spin, it's like a little heading indicator, you just got to spin the card to indicate your magnetic heading on top. So what we're going to do is going to rotate this so we're 180 is on top. That. Right, the arrow doesn't move, but it will tell you the magnetic bearing to the station. So it says fly east, you'll get to the station. And now lastly, the RMI standing for radio magnetic indicator. The heading now is not controlled by you, it's controlled by a magnetometer or compass or whatever. It's automatically going to set your heading on top. Whereas this, the adjustable card, you have to spin the card for your heading to be on top with this little knob. So it's going to look the same way, except now this moves automatically. So there's one main error with NDBs. That main error is going to be called homing. I call it wind homing. Because it doesn't have radials, right? You don't really know if you're flying a correct course to something or not. The wind's going to blow you away. So you're going to do this little weird snake path to the station. It's called wind homing. Eventually, when you get really close to it, you might kind of do circles around it. So yeah, just keep that in mind. NDBs really do suck. There's not too many of them around the United States still.